So today is we talking about LX6C. How to get started with the Codesys. Okay. So let me share my screen first. So first part we are talking about the basic of Codesys, about how to log in, how to create the data, and the support protocol of Codesys. Okay. So first thing first, about the project, we need to log in, right? So this login, we only to click the scan network when the PC and the PLC and the same LAN, or you can directly using the Ethernet cable to connect with between the PC and the PLC. So because our WECON PLC, the default IP is this one, 192 point. So sorry, because this default IP is this one. So before we want to connect it, we can set our PC IP into the same LAN, same segment, right? So if you want to change the IP setting, so you can use this WECON Codesys tool, this one. So when you install the WECON Codesys, so you will be able to automatically to install this tool. So you like this icon. So it is you can using the Type C cable to connect with it. So you can read the IP and say as static IP or DHCP. So about how to download, actually it is as long as you log in into the device, then the project will download automatically. Okay. So if you first time download, it will show like this. The application don't exist, so you can click yes. Or this one is if you changing the project, and we usually to select second one, login with the download. And about PC side also has indicator lamp. So on the bottom right corner, so you can see here is the Codesys gateway. So we need to make sure the gateway is on running. So then we will when we log in into the device. So you will see it is green lamp. So which means the gateway is running normally. So red means unable to establish the connection, and the yellow is unknown connection status. And the last part about the operation part is about save the project as active. Sorry. So you can, like normal project of Codesys, we can see there are a lot of file on the founder. So after we save this one, so you will like the zip into the only single one file. So we can transfer this the PLC program easily. So here I show a video to you guys. Because first time we install the Codesys, it does not have the device configuration, so we need to install the those XML file first, so we can select the 6C in the Codesys. So here I install WECON Codesys package. So it need us to close the Codesys first before the install. So after this package is installed successfully, then we can go back to the Codesys software. Here I install the XML file for PLC. So again, then after we install, then we can select 6C PLC. So here I new the project, a standard project. Sorry? Then let me share screen my again. Oh, okay. Can you see now? How about now? Can see now. So after we install the package, right? So we can select. Uh-huh. Uh-huh. But I check on my side. It is showing status. Okay. A few minutes. Maybe I need to quit the meeting and join you again. A C. Can you guys see my screen now? I'm opening a video. So first, yeah, of course. So okay, it's fine. Well, I'm encoding, recording locally. Okay. So first we need to after we install the Codesys, if you don't have the 6C device, so we can install this package individually. So after we install successfully, then we can select 6C device when we create project. So here I create a standard project for 6C PLC. So here is for select the the programming language. Okay, so here I select ST. So here I create some variable and so here I create a variable and oh, sorry, here is for logging first. So you can see the first time because the IP, the PC IP I set wrong. So first time it cannot scan successfully. So here I change my PC IP. Then I click scan network again. Scan the network so we can see the 6Cs appear. So now we going to create some variable. This is a boolean type, and this integer type. So I create a simple project of 6C. Then logging into the PLC. Here is for set the task interval time. So which means it running cycle. How many times it is cycle once. So you can see I trigger the B value 1, so it will execute this formula. So this is the first part I want to introduce. Any question for first part? Uh-huh. I will choose the code. Okay. So okay, so okay. So second part, we are introduced about this data type. So about the basic data type, many is about the binary data type is boolean and byte, word, double word, and long word. So we can see this lower limit and upper limit. So it is different. And also there has a decimal data type like the short integer and on-site short something like this, on-site and site integer, and double and long, and also the last one is real and long real. So why does the integer data type have two different types? One is you can see one is the binary and one is the decimal, because when we logical operation, it requires this binary type, and arithmetic and comparison, it needs this number, which means it is the decimal type, like addition and division and multiplication and yeah, that's like this. And the below is the equal, no equal, and the greater than, lower than, and lower equal, something like this. And here is the floating data type. So we can see this number is very big. Just a quick view for this part. And also we have Codesys have this data type data type. So like time, long time, and data and time. Yes. So also we have a string type on Codesys. So one is the W string, which is Unicode format, and also a string is ASCII code format. So WS string is because it usually Unicode is occupied more bytes on capacity, so it is require more long. Default is I remember is 80 length. So corresponding function is, or string is on a standard library, and this W string is on a standard 64 library. So we can add this library on the. So for example, here I open a library manager. So here we can add also because it's I first time to add this library, so you need to search for a while. So this standard 64, so we can click OK to add this library. So you can see it is appear on my list, library manager list. So how to declare our variable? So it is syntax is as follow. So first is this identifier, and the following is the data type. So we can see like the this screenshot. So on the left side is the name and the right side is the type. So about the naming rule, we can contain this letter and number, but we cannot start with the name with the number, and also we can only start with one underscore. Okay, so like no spaces and no limitation. This is PLC open naming rule. Okay, so we can see on the Codesys online help for this part. So we usually suggest you to write the name as the camel case. So something like this, like security door open. So it is first is lowercase and the following words is uppercase. So here is about the initial value. So expect this name and type. So it will following actual at least initialization value. So if we have there is no initial value is specified, the default value is the 0. Okay. So also we have constant. Constant means cannot change, cannot write in the application. So when we is online viewing, so it will marked with the following C icon, like something like this. So it is also when we declare this constant value, we need to add this constant keyword. Okay. So about how to comment code. So we usually is using this two slash. Two slash is for common sign. And also if you want to comment multiple lines, we can use this underscore. Oh, sorry, this sign. Also, we have auto declare. So when we implied the code on the POU, so usually it may have error line. So it will pop up this kind of window. So we can directly write into this window. So it will add to the declaration area. So let me show you. So for example, here I didn't declare any variable, right? So here I write value. So here we can see there is a lamp. So we can click it and you can see we can change the into the boolean type, for example, then you can see it is automatically add into this declaration area. So also we have a scope for our variable. Like if we declare on a POU, so it just able to take effect on the POU part. But if we create a global variable list on the project, it will take effect on the whole project. Okay, so when we create, we can right click the application, so we can see here is one global variable list. For example, here is a global so here I can call this global variable. Okay, I can operate it on the POU. Something like this. So global variable is recognized throughout the whole project. So the scope region is different. So here is about the I/O declaration. So we have three methods to declare the I/O. So first is using the AT command. This method is no need to require any I/O mapping. And the second one is declare in the device editor. This one second method need to mapping the I/O configuration. And the third one is to use this keyword variable and this config list. So its syntax is like this one. Is have a percentage sign, and this is I means the input, Q means the output. So here is the size is, for example, it is single bit, so I use the X. And the following is the number. So before we want to use the I/O, local I/O, we need to add the device. Okay, add device local bus master, and add the device list 080AEAYEXYT. So then declare the variable and configure this variable in your I/O map. Wait a moment, I loading my project. So for example, here I add the device, okay? So select this local bus. And add this my local I/O. So here I mapping into the this our actual output and input. So for example, here is so something like this. So we can control the I/O on the POU. So we also have some advanced data type. First is the structure, and the second one is enumeration and union and allies. The first structure is something like we using on the C language or on the Siemens. Okay, so we can define some user-defined structure type. So define a structure member and initiated the structure variable. When we can use the variable to call it. So it is something like this. We can using this dot to call the actual variable. Enumeration is to using on something like the month or weekday. We can using this enumeration. And the union is similar to the structure. So we can define the union, and we also it is using the union name and dot the variable name to call this variable. About the allies is something like the represent to the exist data type to another name. So for example, I can rename its string 80 to this my string. So for example, in my project there is many variable using the same list string 80. So so if I want to change this length, maybe I need to change multiple times in the project. But if I using this allies, I just need to change the type once time is enough. And another one is the array. Array is we using this this sign to call it. Okay, so this is the one-dimensional array. It's like this, and the two-dimensional it is using this side, and this is three-dimensional array. So it is a little bit like the advanced language. So we can using the index to call the value. Okay. So the last is about it's about our Codesys 6C supports protocol. It's like following. The first is the PLC handle. So this is actually is the Codesys V3 protocol. So we seen this one protocol, so we can communicate with third part device like HMI or other device supports this Codesys protocol. And the following is like the EtherCAT master and the Ethernet IP. So these all supported. Okay. Also about the OBC and Modbus. So if you guys want to check how to communicate with those protocol, you can check our video on YouTube. So about the second, I want to introduce the EtherCAT. About this part, we need to introduce some framework. So here we can see Codesys on software side, it has something like this drive configuration and cam editor. This is for modify the ECAN table. So we can draw the table on this CAN editor, and the CNC and the axis group. So this part is for something like the robo arm. 啊，怎么？没声音？Can you hear my voice now? Okay. So just a quick view for this part. This something like a framework. So has SM3 basic CNC and robotics. So it is all about the soft motion function block. And about the PLC standard, it's established by the global famous group, famous company to develop this programming standard. So we can see there are two guys is from the Codesys. Okay. So here is the XC type. We have three type axis. One is the CIA 402. So this is okay. Sorry. Can you see my screen now? Okay. So first is the CIA 400, 42. So this our servo driver axis is using this one. Okay, CIA. So the second one is virtual axis, and the third one is free axis. Something like the encoder is using this free axis. So the second one is the virtual axis is usually using on something like you can see here is pure position reference source or something like this. So our velocity on the Codesys part, we have velocity ramp type. So we have four types to select. One is the square sign and the quarter ratic, and one is the trapezoid. And here is the very important setting on the Codesys is about the scale. So for example, like our the 60 70 bits encoder type motor. So like this A1F, right? So it is two power to the 70s power. So it is corresponding to the so I'm open a calculator. To the power 17th. So it is corresponding to the decimal number is this one, right? So 131K. So it's because on the Codesys is input this hexadecimal number. So it is corresponding to the 20K. So here we input 20K here. All right. So it is this increment in corresponding to the 1 turn. So for example, I output this much. This pulse number corresponding to the 1 turn. Okay. So for example, if for example, so for example here 65K is corresponding to pulse is corresponding to half turn of the motor, right? So here also, if you have the reducer gear, so we can input on here. So because I don't have the reducer, so I directly input on here is 1. So for example here I want to my user application, sorry, user unit. If I want to corresponding to the 1 degree, for example, I want to use on the 1 degree in my project. So here I can input, for example, $316. So which means if turn 1 if I turn 1 degrees, it will output this much pulse, right? Pulse number. So for example, 1 turns is corresponding to the 100 millimeter, for example. So if I turns 1 degree, so it is 100 millimeter to divide it with this number. So it is it's actual moving position or on a distance more accurate. So here, because we need to import our EtherCAT XML, right? So here we need to check the monitor parameter of the VD3E. So it is checking on the U2-004 is for checking the firmware number of the VD3E. So we import this corresponding version XML configuration into the install into the Codesys. So general step of how to add the EtherCAT is general step is to first is to add EtherCAT master soft motion and then select the NIC of the PLC EtherCAT. It usually is the Ethernet 1 is corresponding to the EtherCAT NIC. So at the following is to add the EtherCAT slave station, and also which in the previous mention about is CIA axis. So then select the setup, the startup, the parameter of this EtherCAT slave, and set mapping and this application unit. So because Codesys is default is using precision mode. So if we want to set up another mode, we can set up with something like if it's velocity CSV. So we can set up this 9 or 10. This 10 is for talk mode. So you can check on the servo menu if you want to change another mode. So the following part is about the Codesys function block. It is something like the common pins if we using the function block. Like first is axis name. It is when we create CIA axis, you can it is name it is called this one, okay, corresponding to this one. And the enable is, which means is taking effect on when it's true. And execute only execute one time when it's true. So something like down and busy and command abort and like error ID. And also about the function block, and the most important the function block is this one, the MC power, which means the axis enable. Sorry, and something like stop, reset, and homing. And also like this is for position mode. This move absolute and move relative. Okay. And also the jog and move continuously. This is for speed mode. Move with velocity. And also something like the real time parameter. So here I show you how to start a simple single axis project on the Codesys. So here we can see here I programming by the FBD, okay. So before, because I didn't install before, so here I install this XML for VD3E first. Because my firmware is V1.11, so I use this one. So here first I select EtherCAT master submotion. Also this one is also okay. Then add the device VD3E. So we add the CIA axis. So I rename a new name, axis 1. So we need to notice that when we want to using the EtherCAT, we must to drag our POO into the below this EtherCAT task. Otherwise, if we drag the POU on the main task, you will report the error when you running the PLC. So first we need to drag the list MC power, right? So here 3 parameter I using the one variable to control. Because this is if we no use at all, we can delete this site. So here I using the default CSP mode. So I using the MC move absolute. Same the axis 1 and this is execute. And here is for set the target position of the function block. So for example, I want to turn 10 turns for motor. So I say here set 3,600. So here velocity I set one turn. Okay. So because we didn't use, if we didn't use this direction and buffer mode, we can directly delete. We usually make this as default. But sometimes we will resolve this error, because sometimes if we debug our programming, we need to know what error it is show. So after we move to the target distance, then we use this MC stop to stop the movement, and also set the decelerate and jerk. Here we can see here is for select NIC setting. So all right, we need to log in the device first. So select as Ethernet 1. It is for EtherCAT NIC. So another one is for setting the application unit. So here you can see I set the user unit as degree. Okay. Then I download into the PLC again. So after, if the server is running normally, it will show this green lamp. Okay. So here I adding the tracing. We can see the that how it running on when is when it is execute. Here I add another read parameter function block. Read actual position. So I using a variable to accept the function block reading value. So I can add into this diagram also. So I execute this obsolete move because here I forget to enable this read, so it didn't show no any value. So after we enable it, we can see the 3,600 is still showing. So here I change the target position as available. And also add to this diagram, tracing diagram. So you right click to download this tracing and enable those on the function block. So here I set the target position as 7,020 200. So we can see the tracing is showing like this now. So after reaching the target position, it will stop. Okay. So any question for this part? If not, we are moving. Uh-huh. So sorry. So sorry, they didn't understand. Robot. You mean robot? Or okay, kinematic. Oh, okay, okay. What did you want to know about kinematic? You mean 6C? Robot arm. Yeah, we make demo. We make demo before. For Delta robot arm. Okay, okay. So a jerk. A jerk actually is the how to describe about it. Maybe I can show. So for example, this is our well, curve, our curve of the movement, right? So this is the distance about the motor, how much, how long it running. So it is distance. So it is corresponding velocity curve is something like this, right? So first we need to accelerate on the accessory for the first part, and moving constantly, and the second part, and the last is moving decelerate on the third part, right? So it is uh, maybe I need to draw this picture. So because this this part is constantly move, right? So is velocity is a constant, a fixed value. So on the first part, you need to accessory. So it is velocity need to it need to add, it need to increase its value. Okay. So last part we need to stop on the destination, right? So also we need to decelerate the velocity. So it is velocity. It's like this. This is distance curve, and this velocity curve. So jerk is correspond to this velocity. So it is something like this. On the first, the jerk need to jerk need to add into increase, right? So no. Oh, sorry. No. So this curve is for accelerate curve. So it is, we need, because the first the velocity is increased, right? So it is accessory on the first. Accessory when we increase the velocity, and after we reaching the target velocity, then we need to down to 0, right? Then the velocity is constantly, then accessory, this is 0. Okay. Then after we need to stop on the destination place, we need to decelerate the velocity, so they decrease this value. Okay. So also it is it's something like this. It is accelerate and decelerate. So So the jerk is corresponding to the accelerate and decelerate. Okay. So for example, when accelerate the velocity jerk is like this. Okay. So it is it's how to make it's something like the so for example, accelerate is this y, right? So jerk is corresponding to this k. Okay. So actually, yeah, yes, you are right. Yeah. So last part, maybe I need to quick review. Okay. Indeed, we meeting is too long. So LOD, let the good diagram is because many engineers familiar with this language, so I using this to introduce. Okay. So when we create a POU, we can select this ladder diagram, and so here is the toolbox, like this moving most this general and Boolean operator, math operator, and the function block. Okay. Something like this, and here I show some of them. Okay. Then we meet ending this meeting. So here I select as LOD. So network is like something like new one line. Okay. And also here is a box, and box with ENA, ENO. So you can see it has the condition. So box is without any condition, it can execute automatically. So this ENO, which means we need to meet this condition, then it can execute one time. And also this assignment, if you have some pin is empty, you can add into the box. And here is the jump like other PLC. You can create a label, then you can jump into something like label. Return means the end, okay, which means below this this line on the programming will no running. So it's similar to other PLC. Label. Wait a minute. I check where is label. So here here is label 1, right? So for example, oh sorry, I spelled wrong. So you can see you will something like this. You jump into the new network. And also this branch and execute. And add and alt X or this is for boolean operation. And here is math. So something like this. Add making the addition calculation, and this subtraction and multiplication and the division. And here is for compare. You can see here is the equal, no equal, and lesser than, lesser and or equal, greater than, greater and equal. And here is for binary select. So for example, when we're moving on a curve, you can see if the G value is false, it will select as ion 1. If G is as true, so it will select as ion sorry, if this false is ion 0, is 4, if 2 is ion 1. So for example here the select results. Oh, sorry. Here's bully. So because I not able to so for example, this bully value is for example, so when this bully value 1 is true, then it will output this 20. Okay. And let me see, because I'm not able to log in for the moment, so I need to change into the PC. So if you want to simulation on the PC, you can. Oh, sorry, it is crashed. You need to open this one. This is for a simulation on the PC. You can click this start PLC. Wait a moment, I'm loading my Codesys. So besides the select, and here is for, so we also can check this multi. Okay, so now it's open. So this K means if the value depends on the K, so it will output the first one or the second one. For example, the K is 10, then you will output 10. Okay. So so about this file, you can check on the Codesys online help. And this limitation something is something like the mnemonic input in HMI, which means if you input cannot exist this upper limit and lower limit. So for example, lower limit is 0 and the upper limit is 100. So if you input 125, so it will output as 100 directly. And if you input minus 10, it will directly output this 0. Okay. And this move is the move the value b move. Okay. Same to the other PLC instruction. And this convert the data type. So for example, we can change boolean to integer. Okay. So something like this. And the function block is rising trigger and the falling trigger. And here is for set reset. This means the reset priority or set priority. Okay. RS means reset priority, and SR means set priority. And here is for timer on and timer off. And here is counter up and counter down. And also if we want to add some assignment, we can, for example, here add this instruction. It can multiple inputs, right? So I can add this input into here, multiple input. As long as this function block supports multiple input, they can continuous add. Okay. Also, we can set this this branch and it gives another function at conduct. Okay. Okay, so you guys, if don't any other question, then we end this meeting. Okay. Servo complete time. Servo complete register. So maybe we can answer your question on the group, okay? Because I didn't understand what did you mean? Any other question for the meeting content? I mean, okay. If not, we close end this meeting. Oh, okay, okay, okay. Thank you for you guys attending. Okay. See you next time. Goodbye. Yeah. Of course, of course. I will upload into the YouTube. Okay. So you guys, you can review the recording video. Okay. You're welcome. Goodbye.